Hi there, geometry students. It's Mr. Pouts again for section 4.4 video. Um, Today we're focusing on this goal, which is all about congruent triangles, as we've been doing this whole chapter. But here it says I can prove that parts of two congruent triangles are congruent. So we're going to use our ability to prove things congruent, prove triangles congruent. We're going to use that then to show that the different parts of those triangles are also congruent. And our mascot for today is the Falcon, which, hey, it's a mascot for our school all the time. And who knows, maybe we'll hear the sounds of a falcon in this video. Dum dum dum. Well, anyway, make sure you have that goal written down, please. And we're really just going to I'm going to give you one concept that's for today. We'll do an example. We'll actually do a couple proofs with it. That's mostly what we'll be doing in this video. So, here is what we're getting to today. So you know that with side, 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 angle, angle, and angle, angle, side, you know how to use the three congruent parts of two triangles to show that those triangles are congruent. So whatever three are there. So the word here is, that's how you show two triangles are congruent. But once you know that two triangles are congruent, there's some conclusions that you can make about the corresponding parts. Because if two triangles are congruent, by definition, all its corresponding parts are congruent. So, so this is right here. It says, by definition, corresponding parts Whoa, that was interesting. Not sure how my NG moved all the way over there. Crazy technology. Corresponding parts of congruent triangles are congruent. And that is, that's actually a definition. So we can use this as a reasoning for our proofs. And I'm going to allow you to use this abbreviation of CPCTC. CPCTC stands for corresponding parts of congruent triangles are congruent. All right. So if you want to put that into your own words, feel free to do so. How would you describe that to someone if you had to tell someone that what CPCTC means? All right, let's use it. Two proofs I've got here. Actually, I've got just one example here for us. It says, if you look at the top here, are the two triangles shown at the right congruent? Why or why not? Well, I look at it and I see a set of angles congruent, another set of angles congruent, and then a side that's congruent. So since we have two angles in one side and the side is not included, that could be proven by the angle. So we'll say yes by the angle side theorem. So since they're congruent, can you conclude that angle Q and angle T are congruent? Well, most certainly. You could have used the third angle theorem for that one, but we could also do it because of CPCTC, because corresponding parts of congruent triangles are congruent. We could also say then that this side, QS, is congruent to TX. We can say that RS is congruent to WX, simply by the definition of congruent figures, CPCTC. All right, let's do a proof using this now. So, proving parts of triangles congruent. We're given that segment GK is the perpendicular bisector of segment FH. So think about that for a second. And I'm going to start writing a two-column proof here. First step we always have is the given. So GK is, we're going to abbreviate perpendicular bisector, not peanut butter, perpendicular bisector of FH. And I could go for a PB and J right now. All right, what's your reasoning? That's because it's given. So that would be step one. Now let's think about that a little bit and how we can connect that to our picture here. If it's a perpendicular bisector, I mean, first of all, that word perpendicular means you have two right angles. So let's just say that angle HKG and angle FKG are right angles. That's from the definition of a perpendicular bisector. And then, you know what? There's something else you can say from the definition of a perpendicular bisector. You can say that these, since it bisects this segment, cuts it in half. So FK, segment FK, is congruent to segment HK. Definition of, well, we will change that. So it says definition of a perpendicular bisector. And I'm going to take that then and clone it. If only, whoops, that's not the clone button. There we go. So we've got a lot of stuff now. Oh, I probably should have said after step 2 that those two angles are congruent then, because all right angles are congruent. So you can change that. You can put that in step 4. You can switch that and put that in step 3. But angle HKG is congruent to angle FKG because all right angles are congruent. All right. Anything else from this picture? Oh, if it's the two triangles, we have that GK, segment GK is congruent to segment GK. It's itself. That's always a good one. That's that reflexive property that we learned a long time ago already. And it's a good thing we did learn it because we're using it. Oh, those two triangles are congruent then. Side angle side. So triangle, let's say FKG. Make sure it's in the correct order. For saying FKG, that would have to be congruent to triangle HKG by the angle side or side angle side postulate. So we proved the two triangles are congruent. But we have to prove that segment FG is congruent to segment HG. But very simply, there's only one extra step we have to do. We can say that segment FG is congruent to segment HG because corresponding parts of congruent triangles are congruent. CPCTC. So if those two triangles are congruent, then all their corresponding parts are also congruent. And there is our proof. And we got a big smiley face. And I think we're going to hear from the Falcon himself. Wait for it. Oh, 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 oh. Oh, yeah. Did you hear that? I hope you heard it. That was the Falcon. It's actually kind of anticlimactic, if you ask me. That was a Falcon call. You know, we have all these sounds that we have for, we call that's a Falcon call. There's, duck calls and everything. I wonder what Falcons think the human call is. Anytime they see someone yell, "Hey, you!" Who knows? So that's something to think about. Food for thought. All right, well, that's that proof. I think I have one more that we're going to go through that'll help us with this idea of CPCTC. So again, this is a two-column proof, and it says you're given that segment ON bisects segment on bisects bisects angle JOH, and angle J is congruent to angle H. And that's already labeled on our picture for us. Oops. But with that that idea of bisecting an angle has nothing to do with the segments then. It just cuts the angle in half. So we can then say that segment, or if it bisects angle JOH, it cuts it in half. So you have angle JON and angle HON. John and Han are congruent because it cuts it right in half. That's from the definition of an angle bisector. So you can go ahead and label these two angles here. Incongruent. Hey, our handy dandy reflexive property again. Segment ON is congruent to segment ON. They're on both triangles. That is the reflexive property. So we have this segment's congruent. And looks like we have enough information. Angle, side. Those two triangles are congruent. So triangle John and triangle Han are congruent by the angle, side theorem. Aha. But we're trying to prove then that segment JN is congruent to segment HN. And we can prove that because of our CPCTC that we talked about. Corresponding parts of congruent triangles. Now that we have that those two triangles are congruent, we can say that their corresponding parts are congruent. So JN is congruent to HN because corresponding parts of congruent triangles are congruent. CPCTC. And that's that. Big smiley face. And we're done. 5 steps. Nice. And of course, there are different ways to write this. Don't feel like this is the only way you have to write this proof. But this is just the way that I wrote it, and I wrote down the stuff I knew, the stuff that I could figure out from the given or the picture, and had enough information to show that those two triangles were congruent. Now, don't forget to self-assess your goal. You can also answer find the error question in the closing questions. See if you can find the error in this proof, and then self-assess the goal. Please don't forget to self-assess the goal at the end here. All right, until next time, both me and our falcon friend, hope you have a good rest of your day.